In problem number 11, we're given some information about the behavior of a function, and we're given some data tables. And we're supposed to match the table to the description of the function. Now, this is one of those problems where we're not going to get an answer that makes it look like we exactly have what they're looking for. But we're going to be able to identify the best of the possible options. Now, they tell us that f prime of 5 is negative 3, and they tell us that f is concave downwards, which means f prime prime is negative. Well, now we can do some analysis. If we start with table A, let's find the average rate of change of f from 4 to 5. So f of 5 minus f of 4 all over 5 minus 4. So you see we're going to get 4 minus 8 over 5 minus 4. It's negative 4 over 1, or negative 4. Okay. Now let's find the average rate of change from 5 to 6. Once again, we're going to use f of b minus f of a all over b minus a. It's going to give us 0 minus 4 over 6 minus 5, which is negative 4 over 1, which is negative 4. So what we've found is that, roughly speaking, f prime of 4.5 is approximately negative 4, and f prime of 5.5 is approximately negative 4. Now, what we can do with this is approximate f prime prime now at 5 by using the same difference quotient. So we'll do f prime of 5.5 minus f prime of 4.5 all over 5.5 minus 4.5. Negative 4 minus negative 4 is 0 over 1, which is 0. Well, we don't know that these are exact values, but our estimates lead us to believe that the second derivative is 0 in the neighborhood of x equals 5. And if the given information tells us that f is concave downward on this entire interval, then f prime prime is supposed to be negative. So all we've concluded so far is that A is not going to be the answer we choose. Now let's repeat this process for table B. Let's find the rate of change of f from 4 to 5. So again, we're going to do f of 5 minus f of 4 all over 5 minus 4. In other words, we'll get 6 minus 8 over 5 minus 4, which is negative 2, negative 2. Now let's find the rate of change from 5 to 6. Remember, again, we're using the difference quotient here for average rate of change. F of b minus f of a all over b minus a. So 2 minus 6 over 6 minus 5, oops, which is negative 4 over 1 and negative 4. So you can see that the average rate of change of f is approximately negative 2 before x equals 5 and approximately negative 4 after x equals negative 5. So what's happening at x equals negative 5 could be that the average rate of change is about negative 3. And now let's go find the second derivative. In other words, f prime of 4.5 is approximately negative 2, and f prime of 5.5 is approximately negative 4. So we can say that f prime prime of 5 is going to be approximately this difference quotient. Negative 4 minus negative 2 all over 5.5 minus 4.5. Give us negative 2 over 1, which is negative 2. So right now, B is in contention for consideration because the average rate of change of f, according to the table in B, is going to be about negative 3 when x is 5. And we see that our second derivative is negative, indicating that f is concave downward. So D is in consideration. Let's do a little more investigation. Running a similar analysis to the data in table C, we can see that our second derivative is going to be approximately a positive 1. If our second derivative is positive, then our function is not concave downward, so table C is out. Now let's repeat the process for the data in table D. Analyzing the data in table D tells us that the second derivative of f in the neighborhood of 5 is 0. Well, again, if the function has to be concave downward, we should have a negative second derivative. Now let's repeat the process and analyze the data in table E. And the data in table E suggests that the function f will be concave upward because we can see that the second derivative of f is going to be a positive value. So E is out, making B the only answer that could conceivably, or that would most accurately reflect the description of our function. Hopefully this video is helpful. Thank you for watching.